Got to give the people what they want. Bass, right here, we're talking about basic, that's not how you spell basic, basic factoring of polynomials. Okay? First off, let's talk about factoring. It's when you break a problem, when you break a problem into its factors. Factors being the smaller pieces that you can multiply together to get the original problem. Okay? So we're going to do some factoring, breaking down this thing into smaller pieces, the smaller pieces that we can multiply. Actually, we're going to be breaking it down into the smallest pieces. Okay? So hopefully you have that down. Let's do an example, right? So if I said factor 4, you would factor 4 and you break that down into 2 times 2, right? These are the factors of 4. So we're going to do the same thing with the polynomial. All right? So let's give an example of a polynomial. Example of a polynomial. Polynomial is something like 3x minus 12. This is a polynomial right here. So we're going to break it down into its factors, and the way we do that is we find the greatest common factor of these terms. So I have this term 3x, and I have this term 12. And I need to see what can I divide out of both a 3x and a 12. So I'm seeing, okay, this has 1x, this doesn't have any x's. So I can't take any x's out in common. But this has a 3 and this has a 12. What can I divide out of both a 3 and 12? Even better question, what's the biggest thing that I could divide out of both 3 and 12? 3. So I'm going to divide the 3 out, and then what am I left with? Well, 3 divided by 3 is 1. X is left because I didn't do anything to x. Here's a minus. 12 divided by 3 is 4. Perfect. My final answer is 3 times x minus 4. So 3 is a factor, and x minus 4 is a factor. I just broke this one question into 2 factors. 3 times x minus 4. You might notice that it's like the opposite of distributing. Okay? So let's even put a star. Notice that this is the opposite of distributing. Okay? So let's take another, make sure you can get that. Let's take another example. It says 6x squared minus 18x to the 4th. Okay? We'll just take something basic like this. Alright? So I have a 6 and an 18. What's the biggest thing I could take out of a 6 and an 18? Well, I can divide a 6 out of here and a 6 out of here. So I'm going to pull a 6 out. Now notice, I have 2 x's here, and I have 4 x's here. What's the biggest group of x's I could take from each? Well, I could take 2 from this one, and I could take 2 from this one. So, what I'm going to actually divide out is 6x squared. So now the question becomes, well, what do I have left? Well, notice, if there are 2 terms here, I'm always going to have 2 spaces on the inside. This is a subtraction, so I'm going to put a subtraction sign. 6 divided by this 6 leaves me with a 1. I'm not going to write that down. Or actually, I will write that down. X squared, and I took away 2 of them, so there are no x's left here. So the only thing I have is a 1. 18 divided by 6 leaves me with a 3. I had 4 x's, but I took 2 of them out, so that leaves me with x squared. Okay? And notice, if I distributed this back, I would end up with the same answer. Okay? We'll leave one more example for you all to do. Example 3 says 16x squared minus 30. Just kidding, we don't want to do, yeah, we can do that. Minus 30. So I got to factor out of here. So hopefully you just did it. But if not, you're thinking, okay, well, what can I take out of 16 and 30? I can take a 2 out. I can take a 4 out. And that's it. No, I can't take 4 out. I think the biggest thing I can take out is 2. So I end up with a 2. This has 2 x's, but this one doesn't have any, so I can't take any x's out. So I'm left with 2. Now what's left? I need 2 terms. Boom, boom. 16 divided by 2 is 8. We still have 2 x's there. 30 divided by 2 is 15. This is now factored. So this is basic factoring of polynomials.